So in the previous video, we had briefly discussed Python variables. We discussed how to write comments in Python, and we discussed a bit about data types. Now in this video, we're going to continue on our Python discussion. And an important thing that I forgot to mention about identifier names in the previous video is that we cannot use reserved words. Now what are reserved words? In Python, there are specific reserved keywords, for example, for, while, if. There is break, there is continue, there is return. There are many reserved words. So what are these reserved words? They're basically special words which are used to signify the start of a particular syntax in Python. For example, when we want to start using an if condition, obviously we start with the if keyword. We can even use the elif keyword and so on. Now, if we were to use these as our variable names, then that would not be permitted by the language because it would be quite confusing whether you are starting a variable name or whether you are intending to, actually start an if condition or a for loop and etc. So that's the reason why these reserve words are not permitted, because they create confusion and the compiler cannot, and in this Python's case, the interpreter cannot understand whether you're trying to, write an identifier or whether you're trying to start a particular syntax. Now, to demonstrate how it is not permitted, I'm just going to try to name a variable for. Now, obviously, over here we get this invalid syntax because the compiler sees for, and then it's actually attempting to match it with a syntax like this: for variable name in. This is just one of the many ways in which you can define a for syntax. There are other ways as well. For variable name in XYZ. It's trying to match this with this syntax because it has seen for. So that's why it's throwing an error, invalid syntax. All right, now we come to data types. So what is a data type exactly? A data type is nothing but a domain of values that are permitted to be held by the variable, as well as a set of operations that are defined on it. Set of operations defined. So what that means is essentially, if I have the number data type, right? Then I can have values like 50, 30, etc., any numeric value, and I can do things like addition, subtraction, etc. on these values. What I can't do is things like concatenation. Maybe I would have to convert them to a string first, etc. So a set of logically defined operations as well as the domain of values that are permitted to be held by the variable is referred to as a data type. Now in Python, we have the following data types. As you can see, I've mentioned them above. We have the number data type. Now in the number data type itself, we have int, float, as well as complex data types. So I think it's pretty self-explanatory. If I, for example, defined a number as 50.0 and I attempted to find the type of the number, I would see that it is a float type, right? And now let's come to the sequence data type because that's a bit more confusing. Now, sequence data type basically refers to anything that is ordered and indexed data types. So what that means is essentially, you can have things like lists, strings, as well as tuples. Now, what do I mean by ordered and indexed? By ordered, I mean that they are stored in the data type in the order in which they were entered. They were added. All of the values are stored in the data type in a particular order, and we can access every element. We can access every element in the data type through a particular index or location. What do I mean by that? Right, so let's start with lists, right? I can declare a list like this. I could have 50, 40, I could have a particular string, maybe hi, and this is how we declare a particular list. Now we will delve a little deeper into the various ways in which we can define and declare a list, string as well as tuple. We'll delve into all of that later. This is just a very brief overview to familiarize you with the various data types that can be used in Python. So this is how we declare a list. Now what do I mean by ordered? If I print my list, I can see that all of them are appearing exactly in the order in which I defined them, right? And what about indexed? If I enter, for example, my list 1, then I get the number 40. Now, in Python or most programming languages, every index starts from 0. So what that means is the element 50 is associated with the index 0, the element 40 is associated with the index 1, and so on. This is easier for us to work with these elements and access them. So this is a very easy way for us to access these elements. For example, if I just want to access, let's say, the last element, I can use a negative index which represents the final element in my list. Or I can also use 2 because logically we have assigned 0 to 50, 1 to 40, and 2 to high. So we could access it like this also. But Python allows you to use negative indexes. Negative indices are permitted. That's pretty good. It's very convenient because we don't have to calculate the last index, etc. So that's why negative indices are permitted in Python. Now that's all about lists. Let's come to strings. Defining a string is very easy. I had showed you how to do it in the previous video. So I could define a name variable as Rina, and there you go. I have easily defined a string. Similar to lists, we can identify a particular character in the string by indexing it, that is 0. And as you can see, it is ordered as well. Now, what is this peculiarity of a tuple, right? So a tuple is essentially a way in which we can store any kind of information and we can ensure that that information is not modified in the future. So what do I mean by that? I can define a tuple using these round brackets. For example, I could say, hi, my name is Reena. I could define it like this. And as you can see, it is ordered. And at the same time, you can access it via an index. What you cannot do is modify the last element to another name, for example, CV. You can't do that because a tuple object, you cannot modify it once you have declared it, right? That's not possible. Whereas in your list, if you wanted to replace the final element by instead of high, you could easily do that. And when you print the updated my list, you are able to see the change reflected as well. So that's about the sequence data types. Now, the next thing that we're going to discuss is essentially your sets. Now, in your sets type, what is, okay, my bad, I forgot to enter it as a comment. But in your sets type, what you can see as its peculiar characteristic is that it is not an ordered collection. It is not an ordered data type, and it is also not an indexable data type. So whatever you enter in a set, for example, I enter Reena, name, whatever you enter in my set, it is not guaranteed that these things will appear. In this case, we have it. That is, these names do appear in the way in the order that we entered it, but that is not guaranteed in a set, right? It does some kind of internal calculation, and we'll discuss exactly what is going on behind the scenes of the set. At the same time, you cannot index into the set. For example, I cannot type this because a set object is not indexable or subscriptable. Both of them mean the same thing. So a set is essentially an unordered and unindexable kind of data type. Now, the last thing that we're going to look at is the mapping data type, mappings. So what mappings represents is essentially any kind of mapping from a key to a value. For example, I want my basically particular student's name to be associated with the student's birthday. So I can maintain a particular data type, a variable of a type that alludes to a mapping collection. So what that means is basically I can have a dict, right? So a my dict in which I define key value pairs like Reena's, let's say Reena's birthday is 30/07/2004. I could have Seema's birthday as 20/03/1990. I could maintain key value pairs using the mappings collection. And the implementation of mappings collection in Python is essentially your dictionary data type. So in a dictionary data type, you can define key value pairs and you can also change the mapping of each of these keys. For example, if I found out that I accidentally entered a wrong birthday for Rita, and I meant to enter 2007-2004, I can easily do that. And when I print my dict, I can obtain this value as well. Now, the peculiarity about mydict is that you can index into it using the key to obtain the value. Right. So you can do this and you can obtain the particular value associated with renum. Now, there is one more data type that I haven't discussed, and that is your none data type. The none is essentially just denotes the absence of anything. Like what that means is if I declare none variable to be none, what that means is that nothing is stored none, in none var, right? So there's nothing stored in none var. It's not associated with a particular number or a string or a sequence collection or a mappings collection or anything of that sort. There's just an absence of anything. So this is useful when you want to essentially kind of check if there are any exceptions. For example, if you want to check that a particular whether a value has been filled in a variable or not, or if the value is empty and has not been assigned. If the value was not filled in, it will be of the none type, and you can get that to throw an exception later on in your code. So that's all about data types. This was a very brief overview. I'll be delving into depth in later videos.